problem 6. You want to match the integrals with the particular volumes. Okay, so let's go over each one of these. The first one is volume of the solid obtained by rotating region described by y between 0 and 1, x between y to the power 4 and y to the power 2, about the y-axis. Okay, when x is y to the power 4, you get a curve like this. When x is y to the power 2, you get a curve like this. You see, between 0 and 1, y to the power 4 is flatter than y to the power 2. So, you want y to lie between 0 and 1. In other words, you are looking at the top half. So that's the region. That's the shaded region. You want to take the shaded region, rotate it about the y-axis. By now you understand what will happen. When I rotate this about the y-axis, I'm going to get an outer circle and an inner circle. Outer circle will have radius x coordinate, that is y squared. Inner circle will have radius, that is x coordinate, that is y to the power 4. So my integration, so my cross sections are horizontal and my y coordinates go from 0 to 1. So the limits are 0 to 1, pi y squared minus pi y fourth squared, which is integral 0 to 1 pi y to the fourth minus y to the eighth. So if I notice here, y to the fourth, y to the eighth. So the first one gets C. All right. The second volume. All right. I have rewritten it here. The second volume, the solid is obtained by rotating the region described by. Your x is between 0 and pi by 2. Y is between 0 and cosine x. And you want to rotate this region about the line y equals negative 1. All right, first of all, x is between 0 and pi by 2. So x goes from 0 to pi by 2. All right. And y is between 0 and cosine x. So that's the y cosine x, and this should be 0 on the x coordinate, pi by 2, 0. So that's your coordinate y equals cosine x curve. So notice when x is 0, cosine x is 1. When x is pi over 2, cosine x is 0. So that's indeed your curve. So this region is between x 0 and pi by 2, y 0 and cosine x. So this is the region, and you want to rotate this region about the line y equals negative 1. Y equals negative 1 is a horizontal line at negative 1. So you want to take this region and rotate it. So as you may very well imagine, I'm going to have a huge solid, and you are going to get an outer radius and an inner radius. You see, outer radius is going to be from here until here. So from here, you're going to go up to here, that's distance 1 plus the y coordinate. So 1 plus y is the outer radius. 1 plus y. Y is cosine x. Inner radius is simply 1. So pi outer radius squared minus pi inner radius squared, and because it is a vertical cross sections, you're going to have x going from 0 to x is going to go from 0 to pi over 2. not 1, pi over 2. Okay, so that's the curve, that's the integral. All right, 0 to pi over 2. So for the second one, it's going to be 0 to pi over 2. All right. The third volume, the third solid, you want y to be between 2 and 5, x to be between 0 and square root y. And you want to take that region, rotate it about the y-axis. All right, so that's your x-axis, that's your y-axis. You want y to be between 2 and 5. So those are the two horizontal lines, y equals 2 and y equals 5. And x 0, that's the y-axis, and x square root y. X equals square root y looks like this. Okay, and why does it look like that? Because notice you may think of it as y equals x squared, and that's the same curve. Yeah, so all right, so you're looking at the region between y equals 2 and y equals 5, x equals 0 and x equals square root 5. And you want to take this and rotate it about the y-axis. Rotate it about the y-axis. So you may very well imagine, because it rotates about the y-axis, your cross sections are going to be horizontal. And your limits are 2 to 5. What's the radius? Radius of each cross-sectional circle. Say that for that particular y value, radius will go the horizontal distance, that is x. X is square root y, so pi square root y squared. That's the area of the circle with radius square root y. Pi comes out, integral 2 to 5, that's simply y dy. That's here. Pi integral 2 to 5 y dy. So that is B. The last solid is here. Here is the description. You are going to take x between 0 and pi by 2, y between 0 and cosine x, and you want to take that region, rotate it about the x-axis. X is between 0 and pi by 2, y is between 0 and cosine x, so you take this region, rotate it about the x-axis. So you may very well imagine you have cross sections that are vertical and you're taking integration from 0 to pi by 2. So each cross section is a circle, radius y coordinate. Y coordinate is simply cosine x. So pi cosine squared x integral 0 to pi by 2. Integral 0 to pi by 2 of pi cosine squared x. So the last one is an A. They are all correct. Let's continue next problem in our next video.